Hey guys, what's up? So in this lecture, we're going to be looking at composite numbers and prime factors. Okay, so let's look at the first thing, which is composite numbers. And it says a composite number is a number which has other factors besides itself and one. Okay, so this is basically like the opposite of a prime number, right? So let's look at some examples here. Let's look at 4, right? 4 is a good example for a composite number. Let's just find the factors. So we know that we can multiply 1 times 4, which would give us 4. And can 1 be divided by 2? Yes. I mean, can 4 be divided by 2? Yes, it can. All right. So, and when you multiply 2 times 2, you get 4. And we don't really need to move on here. These are all the factors for 4. So the factors for 4 would be 1, 2, and 4, right? So clearly, because this number, which is 4, has 3 factors, 1, 2, and 4, then it's a composite number because it has other factors besides 1 and itself, and that's 2. 2 is that other factor, okay? So let's look at some other examples. Let's say we have 40, okay? And in an earlier example, we actually found the factors for 40. And there were 1 times 40, right? And what else? 2 times 20, 4 times 10, 5 times 8, and that's it. All right, so there's no more after that. And these are all the factors for 40, right? So 1, 2, 4, 5, 8, 10, 20, 40. So these are all the factors for 40. So it has 1, 2, 3, 4, 5, 6 other factors besides itself and 1, right? So clearly 40 is also a composite number. So most numbers are composite numbers, okay? Most numbers have 3 factors or more, and those numbers would be considered composite, okay? So let's just make a list of composite numbers here, right? And we should start off with it's 4, 4, 6, 8, 9, 10, 12, 14, 15, 16, 18, 20, 21, 22, 24, 25, and so on, right? So it goes on, and this goes on forever. The list really goes on forever, okay? There are many numbers that have more than 2 factors, okay? So I think that's a bit the best representation of what composite number is, of what a composite number is. It just has more than 2 factors, more than one in itself, and that's what a composite number is. So I think we're pretty much fine with that now, and we can move on to prime factors. All right, guys, so let's look at prime factors, right? So a prime factor is a factor of a number which are also prime numbers, okay? So this is really easy to understand. Let's look at um, let's look at 4, right? 4 is a good example. And the factors of 4 are 1, 2, and 4. And we've been seeing that for a while now. These are clearly the factors of 4, right? Now, out of these numbers, there's only one number that is prime, okay? So let's say, let's call it P, uh, P prime, right? I think that's a good example. Let's call it set P prime. If we were to write out all the numbers, all the factors of 4 that are a prime number, it would just be 2, okay? Let's look at another number. Let's look at 40 again, all right? And the factors of 40 are actually 1, 2, 4, 5, 8, 10, 20, and 40, okay? And I know that because we just did that example, okay? So these 8 factors are the factors of 40. So let's look at the numbers that are actually prime. So p prime for 40, okay, which is the prime numbers that are factors of 40. Yeah, let me remove that 40. That's for 4, not for 40. Right, right. So the prime factors for 40 would be 2 and 5, right? These are the 2 prime numbers, and there are no other prime numbers that are factors of 40, okay? So this is one way that you can do this, okay? There's actually another way, which is quite easier, especially when the number gets a lot bigger, right? Because these are just 4 and 40. What if we need to find the prime factors of 2,340, right? That would be much bigger, right? Much bigger, and it probably would have a lot more prime factors, okay? So yeah, let's not look at such a big number though. Let's look at another example where I can show you another method to find the prime factors of a number, okay? All right, guys, so we're going to look at the other method for finding prime factors, okay? So let's say, for example, we want to find the prime factors of 420, right? Which is a much bigger number than 40 or 4, right? We could do the same thing, right? Which is write out all the factors, and that would kind of be more time consuming. So there's actually another method, and it's a very lovely method, you know. I wrote lovely because I really like this method a lot. And you're pretty much gonna divide through by strictly prime numbers. Okay, so let's look at an example here. We're gonna start off with 2, and then you're gonna move on to the next prime number, which would be 3, 5, then 7, and then so on. And that's how you would find the prime factors. But let me just do this as an example. So the first thing we're gonna do is divide by 2. We're gonna start off with 2. Okay. Then we're gonna say 2 can be divided into 420, which it clearly can. Okay. So we're gonna draw a little table like this. So 2 would go into 420, and that would end up being 210, right? Yeah, that is true. And we can continue with this little table. Can 2 go into 210? Yes, it can, again. And you're gonna end up with 105, right? No, we're gonna try 2 again. Can 2 go into 105? No, it can't. It would be 52.5, so it would leave a remainder, okay? So can 3 go into 105 without leaving a remainder? No, it can't either, okay? Okay, so can 3 go into 105 without leaving a remainder? And okay, so let's just check that. Can 3 go into 105? 3, yeah, 3 divided by 105. What would we get? 9. Right, 3 divided by 105, we would get 9. 3, all right, and then we'll have a 1 here, carry down to 15. So it would be 5. Okay, so 3 can go into 105, okay? And 3 into 105 would give us 35, okay? So great. And then we'll start with 35 again, and we do the same thing. We'd start off from 2 again and say, can 2 go into 35? No, it can't. Can 3 go into 35? 3 times 10 is 30. No, it can't. Can 5 go into 35? And the answer is yes. 5 can go into 35. So we divide 5 into 35, and we would get 7, actually. Right. 7 times 5 is 35. And we do the same thing with 7. Can 2 go into 7 without leaving a remainder? No. Can 3 go into 7 without leaving a remainder? No. Can 5 go into 7 without leaving a remainder? No. But 7 can go into 7, right? And the next one would be 11, the next prime number. So it's good to that's why it's really important to know the juvenile prime numbers. I call them that, the small prime numbers. It's good to know that prime number set because it can really help you a lot. So 7 can go into 7, and that would give us 1, okay? And clearly 1 would be the end of this little pyramid here, or little table here, and that would be it. So this would actually give us all the prime factors here, okay? So let's just write them out. All right, guys. So the prime factors for 420, right? Let's call it P prime. I set P prime for 420 would be equal to 2. It's actually all the numbers here that equal to the prime factors, right? PF, let's call them PF. So 2 is 1, right? We don't have to write 2 twice. And then 3 is our prime factor, 5 is our prime factor, and 7 is our prime factor. And we don't really need anything else. That's all we need to find the prime factors, you know? And yeah, so we're good. Also, something that's pretty interesting as well, if you multiply these prime factors, meaning 2 times 2 times 3 times 5 times 7, it would actually be equal to 420, okay? This is why I really like this method a lot. So it's good to just know this method, and we're actually going to use it later when we're looking at the lowest common multiple, which we'll look into later. Okay, so this is a really great method. It's just lovely. You know what I mean? It's just a lovely method. My God, it's wonderful. It's beautiful. You know, and great. So we're finished with prime factors, and we're gonna move on to the next lecture. Okay. All right, guys. So that's it, and I'll see you in the next lecture. And remember to do your best, and God will do the rest.